Go.
Hello, I'm Mrs. Neill, and this is Mrs. Neill's geometry lesson number 22, Polygon Sum Formula. All right, let's get started with the definition of polygon. What is a polygon? Up until now, most of the figures we looked at in geometry are triangles. Now we're going to start branching out. We're going to start looking at not only three-sided figures, but four-sided figures, five-sided, six-sided, and 10-sided figures. So a polygon is a closed figure formed by line segments. Line segments is the key word here, that do not intersect. So your square, your rectangle, your octagon, your hexagon, those are all polygons. Here are some examples. If you notice, they're all closed. You cannot walk into any of these parts. It's all closed by line segments. And none of these line segments intersect. So those are some examples of polygons. Let me show you some examples that are not polygons. Okay, right here you've got two separate figures. This is not closed. So this is not a polygon. Okay, this example is not a polygon. Why? Because you see an intersection of the line segments. Okay, this is not a polygon because it's not closed. I can walk right inside there. So that is not a polygon. This figure is not a polygon because it has to have line segments. If you notice, this part right here is curvy, like a circle. And this part is curvy. There are no curved parts to a polygon. They're always going to be straight line segments. So note, a circle is not a polygon. So if you see anything circular at all, no, that is not a polygon. Let's look at two more terms now. Let's go to convex and concave. Okay, these are some types of polygons that you might see. Convex is nice and regular. If you notice, it looks like a nice figure. It is closed. The line segments are really nice. Concave, I think of the word caving in. It's going to cave in. Instead of having a side, it's going to cave in. And it's going to look kind of like an arrow, something like that. If you notice, this side right here caves in. If I have a point here and a point here, and I draw a line between them, notice how I go outside the figure. So that also tells you that it is concave. Right here, if I have a point here and a point here, and I draw a straight line, notice how I go outside of the polygon. So this one is concave. So if it looks kind of like an arrow or it has a sharp point like this figure right here, it is going to be concave. Now I will say 99% of the time we're going to deal with polygons that are going to be convex. So this is what you're going to be seeing most of the time. Moving on, let's look at naming polygons. One polygon that we've done a lot, and we didn't even really call it a polygon, we called it a triangle, and it has three sides. What if a polygon has four sides? Okay, it's not called a square or a rectangle, it's called a quadrilateral. And within this quadrilateral, you have your squares, your rectangles, your rhombus, your kite. Those are all types of quadrilaterals. And we go into a lot of detail later on about quadrilaterals. If it's five-sided, it's a pentagon. 6 sides is a hexagon. 7, heptagon. 8, octagon. Think of an octopus, 8 sides. 9 sides, it's a nonagon. 10 sides is a decagon. Think of decade being 10 years, so a deca is 10 sides, decagon. And the last one that we use most of the time is dodecagon. So a lot of times it might not say a 5-sided figure. The problem may say, given a pentagon. Well, you need to know the pentagon goes with 5. That's very important. So you do need to know all of these right here. Okay, now let's have a question. How can I find the sum of the interior angles of the above polygons? So if I have a pentagon, which is a 5-sided figure, how can I find the sum of all the inside angles in a pentagon? Okay, we're going to have a formula for today. The sum of the interior angles of a polygon with n sides. N means the number of sides. The sum is n minus 2 times 180. And you do need to know that formula. Where S is the sum of the interior angles and n is the number of the sides of a polygon. Okay, the one polygon we've worked with a lot is a triangle. And we all know that all the angles of a triangle is 180 degrees. I mean, we have been doing that for months now. Okay, so let's put that formula in here. How many sides, number of sides is the triangle? It's 3 sides. So 3 minus 2 is 1, and 1 times 180 is 180. So all the measures, all the interior angles of a triangle is 180. But let's go on, and let's work some of these right here by using the formula n minus 2 times 180. Okay, I'm going to put this up here, and let's look at a quadrilateral. So if you need to, stop the video and write this down. If I have a quadrilateral, I know that's 4 sides and n is 4. So I'm going to put 4 right there in my formula. I wrote it down. Okay, get 2 times 180. So it's 360. And a lot of you already know that all the angles inside of a quad are 360 degrees. But what you will be doing is working some problems. Here I have a quadrilateral. And I've already got 3 of the angles known, and I need the 4th angle. We'll just make you a math sentence here. And I go y plus 53 plus 85 plus 120 equals 360. Okay, add that up. I'm doing some algebra now. Subtract 258 for both sides, and I get y is 102. So 102 right there. You do need to know that that is 360 for a quadrilateral. Moving on. Let's do a pentagon. Penta means 5 sides. So you do need to know that pentagon number 5. So let's put 5 in right here. 5 minus 2 times 180 is 3 times 180. 3 times 180 is 540. And I will tell you, after a while, after you work problem after problem, you'll memorize this. You'll know pentagon, 540. And most times you won't even have to go through the formula. So if you can memorize pentagon, the interior angles is 540, you're going to save you a little bit of time later on. Okay, here's an example. This is a pentagon. If you notice, there's 5 sides. It's not real pretty, but we're just looking at a figure, a polygon with 5 sides. If you notice, I'm making a math sentence. I have n, 2n, 2n minus 10, n minus 20, and n plus 10. Okay, now that's a lot of n's to keep up with. Make sure you account for every angle there. If I add up the n's, I get 7n, and then I've got 20 minus 20 is 540. Finish your algebra. 7n equals 560, and then n is 80. Okay, so n is 80. But let's go back and look at the measure of all the angles. So this angle right here is 80. 2n is going to be 160. This one over here, 2n minus 10 is 150. N minus 20 is 60 degrees. And n plus 10 is 90. So you might have to find out what n is, but then you might have to find out what all the individual angles are also. So if I add up 80, 160, 150, 60, and 90, I can go back and check myself. Those all add up to 540. If they don't, then you made a math error. Okay, we have 2 more examples. Let's look at a hexagon. How many sides is a hexagon? Think about that. It's going to be 6. 6 sides, so n is 6. So I'm going to put 6 right there. So 6 minus 2 times 180, which is 4 times 180, and it's 720. So try to memorize. 6 sides is 720. And let's look at an example right here. Here's a hexagon. I know all my angle measures except x right here. What's this one? That's going to be 90. That's a right angle right there. So I'm going to make a math sentence. I've got 130, x 130, 93, 150, 124, and 90. And all that adds up to 720. Okay, so make sure you add up all your numbers correctly. And then subtract 587 from both sides, and I get x is 133. So this angle right here is 133 degrees. Okay, this is our last example. Let's do an octagon. How many sides is an octagon? Think of an octopus. It's 8 sides. So n is 8. So I'm going to put an 8 right here. Okay, set it up. And I get 6 times 180, and I get 1080. Aren't you noticing the more sides it has, the larger the sum of the interior angles? When we did a hexagon, it only had 6 sides. And the sum of all the interior angles was 720. All right, now we've got 8 sides. So my answer, or my sum, is even going to get bigger and bigger. And it's 1080, 1080. Okay, let's look at an example. Here's an octagon, and I've got 4 angles that are 3x, and I've got 4 angles that are x. So I'm going to write them all down, add up all those x's, and I get 16x equals 1080. Divide by 16, and I got x is 67.5 degrees. So every angle that's an x is 67.5 degrees. How much is the angle that's 3x? If I wanted to do that, I would go 3 times 67.5, and I'd get 202.5. So if I went around and added all those up, it would add up, it would total to 1080. All right, that is our lesson for today. I'm Mrs. Neill. Thank you for listening. That should have been a little shorter.